All right. Excuse me. Good. Good evening, everybody. I hope you are well. Uh, so I've just shared my screen, and I can see it on my mobile device, but I was hoping somebody could help us confirm if you can hear me just fine, so that we can get started, I guess. Thank you very much. I wanted to start off with, before we continue our discussion, of can't even remember. I think it was lecture series number. I don't know if it was number 6 here. Probably not. I think it was lecture series number 6 where we were looking at transformation techniques. I wanted to just give us a heads up. Remember, I'd mentioned that we are supposed to have, or that we would have what we normally call as a mini project or something, but this year it's going to be a very, very scaled down version of the mini project. In previous cohorts, what we've done is we generally would give you about a month or something, typical a month, to work on the project. You come up with an equivalent implementation. But this year, what we've done is we've changed things slightly, and so you will notice from this assignment specification, which will be available on the which will be available on the Moodle, that we expect you to come up with something that is akin to a presentation, okay? A proposal rather. So you're working towards coming up with a proposal, and you're going to present this proposal. We've made available some predefined questions, okay? I'm just going to publish this so that I can share it right away. And the way we normally do this in 5741 is we prefer it. We much prefer to have a situation where all the different students are working on different problems. So these problems are deliberately designed in such a way that they are different, but there's something that is common amongst them, right? The fact that you will all be required to go and harvest textual data. Okay, so I've just shared a direct link to the assignment specification, this document that I have currently projected on the screen. Now, I want to draw attention to, I guess, what one would call section 2 or something, where we are outlining vaguely, right? These are very vague specifications of the different problems. Okay, so your task is just to choose any one of these different questions that we have here. There are quite a number of them. I haven't really been keeping track of how many people are enrolled into the course, so I'm not sure if the questions are going to be sufficient, but in the event they are not, we can always add more questions. Okay, so your task is just to choose a topic. I'm calling these topics, or maybe let's call them problems or something. They're not even problems, they're just vague topics. So your task is to carve out a problem, and then you also kind of outline a proposed solution to the problem itself. But the problem that you're going to carve out and the solution must be aligned to whatever it is you're going to choose. Okay? Now, what I'll also make available is that. What I'll also make available is I don't know if I'll be able to find this document here. Okay, I can share it right away in case people would want to choose topics as we are having class, because it turns out that what we do is we do this on a first come first serve basis, right? So if whoever chooses A1 first is the one who's going to work on A1. Not two people are expected to work on the same topic. So your task is simple. Once you go through this this document here, if you come across, I guess, a topic that you find interesting, a topic that you want to work on, what you must then do is you go to the spreadsheet and just indicate your student ID, your first name, last name, and your email address. That's it. Because this is going to be done collaboratively, people that are going to access the spreadsheet after you've already, let's say, claimed A1, for instance, will not be able to choose A1. Okay, so it's quite a number of questions to go around here. What I'm going to do right away is I'm going to share also a direct link to the spreadsheet itself. Just make sure when you're requesting access to this, you choose edit access. Okay, normally lock it so that there've been instances where if this thing is edited anonymously, I mean, if it allows, if it's configured to allow anonymous edits, it becomes difficult for us to, so I'll just say anyone with this, right? Okay. Yeah. So hopefully this makes sense. And then I just need to confirm here. I'll send out another email. I'm not really sure if all our colleagues that were not available last week are going to be available this week. Probably not. But what I may, I'll send out an email to find out. It's too soon to schedule further, but I'll send out an email. I would want us to schedule the deferred assessment to be administered in the week of the 26th. So either it will be on Monday, Tuesday, or Wednesday. Okay. Now, because the other option that is there is Sunday, by the way. So Sunday, Monday, Tuesday, or Wednesday. And the reason why I'm including Sunday again is because I know that a good number of colleagues that I enrolled into this course, they work, right? So usually weekends, Sundays, for instance, are more convenient. But if you're not available on Sunday, what we can do is we can have it after hours on probably Monday or Tuesday or something like that. Probably Tuesday, actually, Tuesday or Wednesday. Okay, so the test is tentatively going to be either on the 26th, the 27th, the 20th, or the 28th. Okay. I don't know if there are any specific questions that people may have in terms of this assessment, this mini project assessment. You notice that the relative effort required really is not that much, so we don't really expect you to come up with a concrete implementation. It's just a description of the solution, and you don't have to prepare a technical report as with previous cohorts. The only thing you need to do is you prepare your presentation, and then on the 29th, on the 29th itself, or possibly the 30th, we're going to take turns and do these presentations. Okay, because of in an ideal case, I would have loved it if this was done in person, but it turns out that campus is still not conducive for this. In fact, we got details. We got is it notification or communication from management informing us that I don't know if people are on this mailing list, which you should though, but informing us that we're encouraged to actually work from home at least until works at Great East Road campus are concluded, right? So I'm trying as much as possible here to put people in a situation where we are dragging you to a place which has no running water, right? In fact, if you remember, it's one of the reasons why the test was was made so simple such that it would be done in I want to say in like an hour or something like that. Okay, so tentatively these presentations are going to be done virtually. Okay, you just want to make sure that you prepare for that. So it's going to be Wednesday next week. So we have about a week to actually put together, to assemble a presentation, to choose a topic, and to cover out a problem and to come up with a proposed solution. Now you probably don't want to trivialize this, right? Because it turns out that there's quite a bit of thinking that needs to go into this, right? You need to spend a little bit of time here thinking about about this problem here. So if you think you can put together or hack together this in a day or so, it's going to be a bit tricky here. I mean, if you think you can use generative AI tools here to kind of like come up with things, it's going to be a bit tricky here, because one of the reasons why we have these presentations is to try and quiz you, right? Try and see if you understand whatever it is you're going to be presenting. So anyways, I thought I'd mention that. There's a question, yes.
Sorry to interrupt. The document with the assessments, it's only showing the date at the top. It's showing April 2020, and I can only see the index and the bibliography. Nothing else.
Which the document that I've just shared just now?
Yes, the Google Doc. The one I was supposed to get the topics from. That's what.
That's rather odd. Let me just see if I can. I hope I haven't shared the wrong document. Let me just try and see here if I can open an incognito window. Because I've published this, so it should be. Oh.
I'm able to see it.
Weird stuff happening here. Let me just republish it, maybe.
Yeah, probably.
Thank you for that. Somebody's saying they're able to see it. I don't know what's happening here. It looks like I'm offline.
There's one having in a spreadsheet. I think
okay. So I've shared two documents. I think the concern was so this thing is it's offline. I don't know what's happening here. I'm just trying to see if I can. To share this maybe. Hopefully to be able to. Well, when all else fails, what I'm going to do is, I don't know if it's a glitch maybe. When all else fails, what I'm going to do here is I'm just going to share it different. I won't publish it, but this time around I will. Can you just kindly check if you'll be able to access it now? Just use the link I've just shared just now. Should be. I see people there. Oh, beautiful. Yeah. So it's accessible now. I hope you can see everything now. Okay.
Yes.
Yeah. Okay. I think I saw another hand up or something. I don't know if that was. I see.
Yes, Doc.
Mr. Twambo. Yes, sir.
Yes. Sorry for the inconvenience. For me, I don't know if I got you correctly. You said you had posted something on Moodle, but for my Moodle,
No.
data mining doesn't show.
No, Moodle is a bit clunky, right? And we've actually communicated with a number of colleagues. CICT is still struggling to to make sure that Moodle works. So what we use in this course is we use Google Classroom. I said I haven't posted this. I said I will post them on Google Classroom. If I said Moodle, that was a mistake.
Okay.
These things
All
will
right.
be posted on Google Classroom. Everything is posted on Google Classroom for this course. But for now, to probably give people an opportunity to already start going through a document, I've just shared them in the Income messages, both the spreadsheet and the document with the topics. Okay. I just want to kind of ask, please, for you to make sure that you spend a little bit of time thinking about this, right? Yes, it's about 7 days or so. But the sooner you start thinking about this, the better. Especially that we've already covered the crucial aspects, right? The crucial parts of, I guess what one would call a data mining pipeline or something. Okay? So, yeah. Anyhow, I don't know if there are any other questions. If not, I suppose we can continue then, right?
Sorry, Doc.
Yes.
You mentioned that we were supposed to pick now, or
Oh no, you can choose at any time actually, even a day before the. That's a joke though, but you can though. Even a day before the presentations. We are tentatively scheduling this presentation on the 29th, but possibly we'll do them the following day on the 30th. So you want to prepare. You can choose right now, but what I mentioned was that the way these things are done is no two people are expected to work on the same problem, right? So if you choose right now, you're in a better position to choose something that you feel comfortable working on, if that makes sense. It's like you're claiming a question or a topic. You can choose whenever you want to. This thing is available right now. You just want to make sure, by the way, as you're accessing this document, I don't know if you've requested that you, crap. I don't know if you've requested edit access here. You want to request edit access so that you you make changes to the things that are in yellow. Yeah. I think I need to just make sure I protect this sheet as well also, and just make sure that this is all the way up to not 10, but all the way up to 35. Is it F35 here? You know, I'm trying to avoid. No, it's the 29th of this month, so it's next week, April. I think there's a question as in when. It's actually next week, so it's the 29th of, which is a Wednesday. It's one of the reasons why I'm trying to avoid a situation where we have this test. Remember I said the deferred test is either going to be on the 26th, 27th, or 28th, because I know that on the 29th is when we expect to have these presentations. Usually this is like 10 minutes is enough, and that's enough time to go around for everybody. If we don't manage to finish within the time allocated to the course, then we can push it. We can push other presentations to Thursday. And this is obviously during the class slot, right? So this is going to be between. It's going to be between. I see people have already said access requesting for edit access. Thank you very much. This is going to be between 17:30. So we'll start at 17:30, and then we'll go all the way up to 20:30 or something. Which I know it's this year is we have a slightly larger cohort, but we should be able to finish, right? We should be able to finish. Idea. I don't know if there are any other thoughts or questions about this. And I am actually granting edit access and all that right now as we speak. You see there are a series of requests for people to gain access to this. Okay. Again, please, it turns out that if you look at the assessments, right, would be nice if we could put in quite a bit of effort into all of this, right? Okay, I see there's Mwanga here is already trying to claim this question. This is good. Okay, seeing as there's no further questions, colleagues, and Ernest as well. I hope Mr. Ernest and Mr. Tuambo, I'm going to reach out. Please let me know if you're not yet back. If you'll not be back by, let's say, Sunday or something, so that we can schedule the deferred assessment at the time when everybody is around, I guess, or something like that. Okay. Anyhow, not knowing if people have any specific questions about what we looked at last time, last week. I know you are most of you are probably very busy with preparations for the test, I guess, and so you probably didn't really get spend that much time to try and digest the things that we discussed. But a reminder here that we started off our discussion by reminding ourselves that there's this broad spectrum of data mining attribute types, okay? And so what we did is we essentially went through a process of trying to demonstrate exactly how you transform nominal attributes, okay, into nominal attribute into numeric representation.
Sorry, talk to this step.
Yes.
Yeah, sorry, I had earlier requested for edit privileges, but I think he not responded.
Sorry, if you can speak up.
I had earlier requested for edit the document for the topics, but I think it hasn't been granted.
Oh, I've only seen requests from was there's a person with a user was a Dev. I don't know who this is, by the way, and then from Davis, from Mwanga, from Ernest, and Kennedy. I think I've given you. You probably want to refresh the spreadsheet. I think I've accepted that request. And from Levi as well. Hello. Do you want to refresh the spreadsheet and try and see if you can edit the yellow text? This stuff here.
Okay. Yeah, no, it's fine now. Thank you.
Okay. Yeah. So we went through a series of examples. I was context switching, showcasing exactly how we convert, these different sort of attributes. Is it? We realize that for starters, obviously, when you're dealing with numeric attributes, you typically would not really do any sort of fancy transformations, right? You can do a little bit of scaling. Maybe you can scale, but usually you leave them as they are, right? Because they're already in numeric form, is it? Okay, so in our case, I'm going to context switch here again. I apologize if it's confusing here, but I would want to use something that is familiar to all of us. I guess, I don't know. And by familiar here, I'm actually referring to this thing here, right? This thing which is in here. I'm just going to open this. Okay. And this should be pipe symbol, I guess, is a lot easier like that. Okay. So if we go back to our example, is it a reminder here that one of the things that we do as part of exploratory data analysis is that we would do a little bit of inspection, if you remember, right? We can use plain old pandas here and just say I'll just say CS students here, right? Is equal to pd.read CSV or something. I'm just gonna step is equal to that. Playground, like that. Playground. Playground. Right. A reminder that one of the things we said is well, we obviously would want to do a little bit of inspection as part of exploratory data analysis to see to have a better sense of the data set that we're working with, right? So you can check the shape. You know, in our case, we see that we have a total of 69 attributes, is it? And we see that as part of exploratory data analysis, we can do all those fancy visualization techniques, right? But also as part of exploratory data analysis, one of the crucial things we do is we identify the important attributes, right? So it's not always the case that all these 69 would be things that you'd want to use as input into the model implementation process, right? So we pick and choose, ideally, okay? Once you pick and choose, it turns out that what you do is you then identify the different sort of data attributes, right, associated with all of these different attributes, right? So you specify here what attribute is like what, yeah, I don't know what that is here, but what data attribute is student ID, right? And if you look at the companion notebook that has been made available, and I think I may have lost connection here. I don't know what's happening. I believe I lost connection, so I'm just going to have to see if I can reconnect here. Have I lost connection? I feel like I've lost connection here. Yeah, I have lost connection. I'm not sure what is happening here, but I'm just going to switch to see if I can switch to I'm going to switch to, I don't know what's happening here, but see if I can switch to here. So I'm changing connections. I'll be joining shortly. Yeah, horrible stuff. There we go. Sorry about that, everybody. I'm just going to see if I can. Something is a bit off here with my connection. I'm not sure what is happening, but see if I can reshare my screen. All right, there we go. I'm not sure what's happening with my connection here, but I've just shared my screen and this is too problematic. Yes, there's a hand up.
Yes, Doc. I'm just kind of asking if you can accept my request.
I've accepted all requests. What you want to do is you want to refresh the spreadsheet. So if you've made a request, you refresh, and then you should have edit access. Yeah. Okay. There we go. Sorry, can you see my screen, by the way? This is very strange. My computer seems to suggest that I've shared my screen, but I can't see it on my mobile device. Can you see my screen? Okay, wonderful. Yeah, so sorry about that. So doing a recap here, right? A reminder that we said during our discussion, we realized that if you have a data set like this, which has a total of 69 attributes in this particular case, one of the okay, so there's a comment here. Somebody says they can't see my screen. Can I just get confirmation? Thumbs up if you can see my screen, and thumbs down if you can't, so that I can try and see if I can alter things. Okay, so there's a thumbs up. Yeah, so if you can't see my screen, you probably want to maybe refresh or something, and then you should be able to see it. It appears, for those of us that are unable to see my screen, just try and log out and log back in, I guess, or something like that. Okay? Wonderful. So we realize that one of the things that we tend to do when maybe it's a problem on my end. I'll just stop and reshare something. One of the things that we do is we, as part of exploratory data analysis, is we obviously try and identify the types of attributes that we're working with, right? And we try and kind of identify different sort of attributes that we're working with. And true to that, I showcased in the notebook how we systematically kind of identify, or rather, the process we're going through in the notebook to determine what sort of different attributes these are. So if you look at the companion notebook, you begin to notice that, just open it up here, you begin to notice that a certain a portion of the notebook actually has clearly outlined data mining attributes associated with the different data types for the students at risk of failing data set that we're using, right? And so if you go in, I think it's notebook number 4 something, I think it is. If we open it up, we will see that there's a section in the notebook that explicitly states the different types of data mining attributes. Just open it up so that we check here. Anyways, so of importance for us, however, is that, and I don't think this is the one here, it should be 3. Should be this notebook here. Of importance for us is once we identify the different sort of attributes, we then perform the transformation techniques. Okay, so when we met last time, we discussed and looked at examples of how we transform nominal attributes, if you remember. We discussed how we go about transforming ordinal attributes, and I think this is where we ended, right? We had a discussion about how exactly we go about doing the transformation of ordinal attributes. So you can use the ordinal encoder, which is available by default, or you can actually just use a dictionary, right? You can do a mapping, is it? So you identify the field that has ordinal attributes, and then you do a replacement with a weighting, a preferred weighting. So I'm going to scroll down here and get to the stage where we have this part here is what I was talking about, yeah? To say at some point you have got to identify the different sort of data attributes associated with your data set. And then using this information, you then perform the appropriate transformation techniques, right? So in the case of status, what we do is we would obviously transform this using one-hot encoding, yeah? Because it's categorical, is it? Remember, when we are dealing with attributes that are deemed to comprise of categories, and the categories have no meaningful order, or order is not important, then we classify those things as nominal attributes, right? Yeah, they're categorical, quite all right, but most specifically, they are nominal attributes. And we realize that there are two types of categorical attributes that fall within that category, is it? There are those dichotomous attributes where you have exactly two values that you deal with, right? So it's like a binary, 1 or 0. And then you have categorical attributes where you're dealing with more than two values, okay? So it's like provinces in Zambia, for instance, or courses, yeah? So if we had a data set for postgraduate students that are enrolled in let's say, master's programs in the Department of Computing and Informatics, we can view things like CSC 5741, CSC 6741, CSC 5019 as being categorical attributes, right? Because it turns out that courses, CSC 5741, CSC 6741, CSC 5019, these are categories, right? Because all of these are master's level programs, order is not important. We can't sit here and say CSC 5741 is more important than CSC 6741. These are just categories, right? Where order is not important. And because we have more than two as a nominal attributes, we have got to take advantage of one-hot encoding, is it? And we realize that it's actually very simple to implement this, yeah? To implement one-hot encoding. So in the example of these courses, for us to implement one-hot encoding of this, what we'll do is, let's say we have ID course name, right? Course name, course ID or something like that. Assuming we have 3 observations in our original data set, we harvest the data and we have something akin to this, yeah? And it's usually customary. It's always the case that you have some auto-incremental number here, right? Like this. Data mining and warehousing, programming for data science or something, research methods or something like that, right? What we realize is that, and maybe we can even include something like this, right? Is postgrad. Yes. For good measure, we can also include an undergraduate course anyway, right? For 505. Something like this, or something, and then we have no. What we realize is that when we are dealing with categorical attributes like course ID and is postgraduate student, we can have one hot encode these things, right? Now, one hot encoding these is as easy as transposing, right? What we do is we kind of internally we are transposing. But a nice way of thinking about this is we are creating. The heuristic is simple. We look at the unique entries associated with a field that we want to one hot encode. We get those unique entries. In this case, all of these are unique, is it? 1, 2, 3, 4. And then we're going to derive 4 extra fields, okay? By transposing these unique entries, right? Like this. And what we do internally as well is we go through a process of, because we've derived these new fields, right? We have got to assign values for these fields. So we one hot encode each of these different things. And so we check for each of these derived new fields here. Is this equal to, is this new column name equal to the entry for this observation? If it is, then it's a 1. We're one hot encoding. If it's not, it's a 0, right? Like this, 0, 0. And then this one, which has 6741, it will be a 0 here, it will be a 1 here, the rest will be zeros as well, right? And you get the point really. It's be a 0, 0, this will be a 1, like this. We are one hot encoding, right? 0, 0, 0, 1. And the idea here is the way the estimators are designed is they're able to easily make sense out of this combination of numbers rather than this text, this chunk of text here, right? So we're going to use these as input, and we'll soon see once we get to the model implementation process. And then we realize that for dichotomous attributes, and implementing this is simple, is it? Right? You can use pandas get dummies function, or you can one hot encode using scikit-learn, right? If you remember that, right? The examples on how to do this in the notebooks. What's interesting is that, if you remember, I said when you have dichotomous attributes, right? You may be tempted to say, I'm going to one hot encode this so that I have, and by the way this is typically done is you prefix this. The way most of these tools work is you prefix these things with the name of the column underbar, right? So this is going to come out like so. This will be like so. Is it? This will be like so. And then this will be like so. Okay, and then we realize as well that I don't know if that's a is that a hand up or something, or no? Okay. When it comes to dichotomous attributes, I made mention of the fact that there could be this temptation to say, well, if we have yes no here, why can we not just one hot encode the unique entries here to be yes and no, right? So that we have yes and no here, and this is fine, right? But it turns out that this is you're just wasting resources here, right? It's not necessary for you to do this. What you can instead do, because you're looking at a binary value, it's yes or no, it's 1 or it's 0. What you can do instead of doing this is the other option would be to just say. If it's a yes, it's going to be a 1. If it's a no, it's a 0. 1, 0. So you are replacing everywhere where there's a yes, it's a 1. Everywhere where there's a no, it's a 0. Right? But you can one hot encode as well if you want to. So that what I mean here is this, is it? I can have is postgrad. I'll call this T for transformed here. Yes is a 1 and no is a 0. Right? And you don't really have to, if you look at the implementation of this, right? It doesn't have to be, you don't have to really think long and hard about this. You can easily create, a function, right? That just checks if in fact, you can even leverage map functions here. If it's a yes, then if the value is a yes, if value is equal to yes, return 1, else 0. That's it. And then it's going to do the magic for you, right? Anyways, so we did this, and then we realized that we realize that when you're dealing with these other attribute types, just going to open this, I guess. So we had also examples, by the way, of nominal attributes from our data set. And I corrected myself, by the way, again, a disclaimer. I was supposed to make changes to this, but I haven't yet. Technically speaking, if you think about it, A, B, C, A plus A, B plus B, these are not really nominal attributes. These are ordinal attributes because order is important, is it? We know that A plus is greater than D plus. Okay? If that makes sense. Any thoughts about one-hot encoding? And then those, ordinal attributes. The idea here is that if you remember, we said that the simplest way of doing this is when you're working on a problem, right, that involves the use of ordinal attributes. At some point, perhaps doing business understanding or something, you come up with a definition on what these different ordinal values are going to be, what they're going to represent. Okay? In some instances, it's almost always straightforward because internally you have a mapping that exists, is it? If you're using Likert-like scales, for instance, I don't know if you've filled out surveys where they will ask you, on a scale of 1 to 5, state what, respond or something. There'll be something like strongly disagree, right? Disagree. Neutral is neutral. Agree. Strongly agree. And usually the way these are defined is there's usually a scale, a predefined scale. In fact, what they'll tell you is on a scale of 1 to 5, respond, because how many values, discrete values you have? 1, 2, 3, 4, 5. So you already have values mapped onto this. This is a 1, this is a 2, this is a 3, this is a 4, and this is a 5, right? So what you do is you can just do a mapping yourself, right? If this makes sense here. I don't know if this is making sense. Anyways, so doing this is not that hard. What you can do is you can obviously just create a dictionary, is it? Everywhere where there's a strongly agree, just make sure that you replace the strongly agree here with, and this is a string. Remember dictionaries, when you have dictionaries here, you can use strings, right? You can get away with this here. You create a map, a dictionary, and then you do the mapping directly. In addition, what we realized was that, and I think I mentioned this, is you can import sklen, I guess. I normally try to avoid sklen dot preprocessing. I normally avoid looking up documentation. Sometimes it's So in sklen dot preprocessing, what you begin to notice is that you have access to things like ordinal encoder, right? And we showcased an example of how you actually use an instance of ordinal encoder, is it? What you do is you would, and I don't know if I already have an example here, but maybe not, I don't know. I don't know. Can we use this as an example here? Can, I guess. We said that we can do this. Just a scale here. Scales. Strongly disagree. I'm just making things up. I don't think we have. No, I don't think we don't have. We don't have. No, I think we do have nominal attributes in our data set. Is it? Sorry about this. We do, right? It's here. We have an ordinal attribute here. Survey, computer experience. Beautiful. Yeah, this is horrible. Sorry for that. That. We mask this or something. Okay, so we have this attribute, yeah? Is it? And if we were to change this, to cast this into a set, we realize that we have these nominal attributes here, right? No, so what I was saying was that one way of doing this is you can create a dictionary, right? A mapping. So you kind of identify the weights, yeah? What value can best represent no experience? How about less than 1 year experience? How about 1 to 2 years, 3 to 5, more than 5 years? And then once you have that mapping, you can, in essence, don't know if this is making sense to our colleagues here. I'm going to do this. You can create a dictionary is what we said, right? And so we can get our unique entries like this and just say we're going to create a dictionary, and in our case what no experience means is it's a weighting of 1 or something. Less than 1 year experience weighting is 2. How about 3 to 5 years? Well, 1 to 2 rather. Maybe it's a 3. How about 3 to 5? Well, it's a 5. More than 5 years, the weighting is a 10. So I've created this dictionary here, and I can just call this var experience weight or something is equal to this, right? So I create this dictionary, and then what I can then do is yeah, this thing here, 10. What I can then do is I can, is it this dictionary I've created, experience, var experience. What I can then do is I can in essence I can just say I want to get the CS student thing here. Specifically, I want to get this attribute, experience using computers. You know, and few NA here with empty string or something like that. An empty string or something like that. I do apologize here with an empty string like that. So I get this field, right? And what I do with this field is I say I want to map, right? I want to map it with this dictionary that I've created, right? And this is done, right? So that if I then create a new entry here and call it survey experience in code like this, and I check this thing here, it's going to have a field, right? This new field that I've created, code in code. Okay, now because I've created this field code in code, I can now confirm to see if I can confirm now to see if and this is horrible here. Okay, I have to again do this. Sorry about that, because there are still gaps in here, so I have to filter out the things that are not. Is it? So in essence, I've replaced everything that previously had the text with this. If this is making sense, I don't know if it's making sense. But then again, we realize that if you want, you don't necessarily have to use this. You don't have to use this primitive approach, I want to call it, right? What you can do is you can take advantage of what is in sklearn.preprocessing, is it? Because there is ordinal encoder, just like we showcased how you can use the one hot encoder in there. Yeah. So what you do is you create an instance of the encoder, right? And typically, what you would you do is you create this in such a way that they're ordered somehow, right? Is it? I don't know if this is making sense, but also I think I gave this to you guys as as an example, something like that, right? Not knowing if you guys had a chance to kind of look at this or something like that. I don't know if you did, maybe not, maybe not. But anyways, what's important here is that you have got to you've got to create an instance of an encoder, and then you fit it. After you fit it, you can then extract the information that you want, right? It's pretty much straightforward. There's examples in the notebook as well. Okay. Anyhow, again, this example is exactly what I was looking at. It's pretty straightforward here. Now, the next thing that we want to look at here is text, is it? And we tend to obsess a lot about text because text has broad applications, right? I think at some point I hinted at the fact that if you think about the type of data that you find yourself working with on a day-to-day basis, you begin to realize that a significant chunk of it is actually text, right? Social media, WhatsApp, emails, right? Documents that you're working with at work or something like that. It's only now that I guess we've got into a stage where video is becoming more mainstream, especially when you look at these micro-blogging sites, if you will, okay? Now, the question to ask here is, how do we transform text to numbers, right? Well, it turns out that a number of techniques that can be used. These are typically they fall under the broader confines of what are called word embeddings, ideally, right? So this idea that you can kind of come up with a numeric representation of text or content, okay? But what we're going to do is we're just going to focus on two classical approaches, ideally, right? So basic term frequencies, or the so-called bag of words model, and then we'll look at term frequency inverse document frequency as well, which turns out to be a lot more effective than the bag of words model here. But I wanted to start off by reminding us that if you try and relate text or content to some of the things that we've already discussed here, you begin to realize that there's probably certain things, right, that we can borrow from what we've already discussed, right? And in particular, I want to draw attention here to this idea of one-hot encoding, right? And if we were to use this simple text, let's say we have this. We have this, right? If you think about it, what we can potentially do here is, intuitively, we can say, well, we can look at the string of text that we have, and then potentially, in fact, you know what I'm going to do? I'm going to make this slightly more interesting here and just say, this is course, and then this is going to be concatenate. Just going to concatenate this and this. If you think about it, right, we can kind of borrow some concepts that we've already introduced here. It's like we can say we're going to look at the chunk of text that we want to process. In this particular case, it's the course code and the course description. And then we're going to unroll it, is it? We unroll it in such a way that we look at the individual tokens the words that make up the chunk of text. So things that are separated by, I'll call this by space, if you will. So for this one, we extract, I'm just going to say, you know, sometimes when you do this, it's going to be a lot easier if we just do this here. And then I'm just going to, wow. I'm just going to replace the space here, regular expression or something, with, I'm going to replace it with what? Comment that. And then, yeah, this I can easily type what is here, doesn't matter, like that. And then at the beginning here. So if we decide to borrow from what we have here, right, we'll have something like CSC 5741 has this, and then CSC 6741 has this. I don't know why I'm doing this here. Equals, not minus. And then we have CSC 5019. Wow, we have this. And then we have CSC 4505, which we will have this. Now, what we can then do is we can say, well, we want to extract, we want to get a combination of CSC 5741, we just create a long list here, right? 5741, 5019, and this, right? So that we have like a list that will have all the individual tokens or the words or the terms from these observations, but these are called documents. More on that later on. There are 4 of them here, right? Now, if we are to replicate what we did with one-hot encoding, one of the things we would have to do is we would have to cast this into a set, is it? So that we have unique entries. Okay? So cast this into a set. In fact, to make life a lot easier here is, it's okay anyway, into a set, and then I'm going to sort it. I'm going to convert this back into a list or something. And then I'll call it sorted or something like that. So I'm going to convert this back into, I've extracted, in essence what I've done is, I've gotten all of these terms here, right? And then I've extracted just unique entries. I'm interested in unique entries, okay? I'll get these unique entries, and then what I'll do here is I'll say I want to replace the thing here like this. So I'll come here, and then what I'll do is I'll then paste this stuff, right? And maybe I can do it, I can do here a text to columns or something and just say, I want where there's a comma or something to do this, right? So what I would have done here is I've said, I've gotten all the unique terms from the 4 documents. These 4 documents, or these 4 observations here, 1, 2, 3, 4, are part of my data set. So what I've done is I've gotten all the unique terms, all the terms, and then I've gotten just the unique terms. And then what I can then start doing is I can say, if I look at this observation here, the one in yellow here, it's like, is there a 4505? If there is, I can say, I'll put a 1 there. If not, it's a 0. Is there a 5019? No. Is there a 5741? Yes. Oops, sorry about that. Yes. Is there a 67? Is there a 6741? No. So no is a 0. Right? Is there a CSC? CSC? Yes. Is there a computing? No. You get where this is. Is there a data? Yes. Right? Is there graphics? No. Is there a method? No. Is there a mining? Yes. Is there a programming? No. Is there a research? No. Okay. Science? No. Visual? No. Warehousing? Yes. Right? So you notice here, doing more or less the same thing, right? And then I can say, how about the programming in data science? Is there a 4505? No. No, 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 no. So these are all zeros. There's a 6741. There's a CSC. There's no computing, right? But there's a data here, if that makes sense. Data, right? There's no graphics. I don't know why I put this in yellow here, but you get the point, right? There's no graphics, there's no methods, there's no mining, but there's programming, right? There's no research, there's no science, there's no visual, there's no and stuff like that, right? So it turns out that you can borrow, right? And so what I'm doing here, in essence, is in part how most of these techniques, the two techniques that we're going to be looking at, this is how they work ideally, right? In fact, what I'm showcasing here, this one hot encoded version, is one variation. If you look at scikit, the way scikit-learn works here, when you're trying to use count vectorizer, for instance, to implement the bag of words, it turns out that what you can do is you can choose to use the one hot encoding variation, or you can get the actual frequencies, right? In other words, instead of just one hot encoding the terms here, what you can do is you are keeping track of how many times a word is. So you come to 4505 in here. How many times does 4505 appear in this text? 0 times. 5019, 0. 5047, 1 time. And this is a simple example here, but there are instances where you can have a chunk of text that has multiple words appearing multiple times, right? So you're getting the frequencies ideally, if this is making sense. Okay? So in essence, this is like one way, one kind of heuristic that you can use to convert textual content into numbers, right? Remember, the goal here is to convert them into numbers, right? And in fact, what we're trying to say here is that we are trying to move from what we have here, this data frame where we have major program motivation, there's text, and then we want to come up with a modified data frame that has the individual terms, right? In individual unique terms that appear in all the observations of the data set. In other words, the corpus, and we'll look at these terms just now. So what you're looking at here is, this is a bag of words model, right, where we have the term frequencies, and then at the bottom here is the term frequency equals document frequency, right? This notion that keeping track of the count of terms may not really be indicative of what is actually happening. It may be a misrepresentation, right? Sometimes if a term appears multiple times in a given document, it may be cause for perhaps you not to include it, right? Or rather, it may appear multiple times in a particular document, but it may also appear multiple times in other documents, meaning that it's in fact not that important. Okay, and you see this in common words, right? Those things that we defined as stop words, by the way, right? So you would probably find yourself in a situation where, in an instance where, look at acquire here. Acquire here has a 1, but if you are using term frequency versus document frequency, you notice that the value is slightly different here, right? Another thing about this is, if you look at acquire, so maybe I'm going to do this here. In other words, if you look at the value, right, for observation 0, the value for acquire is 1. Okay? However, the value for acquire for the same document 0 here, the value is 0.54, yeah? If you notice here, 0.54. But guess what? When you're using simple term frequencies, for observation 0 for term frequencies, right? The term want here has a value of 1. Meaning that it has the same level of importance with acquire, is it? Because they're both ones. But guess what? When you use term frequency inverse document frequency, you notice that want has a value of 0.30. So in other words, right? It's like when we use TF-IDF, for this same data set, we see that the importance of the word acquire is higher than the importance of the word want. If this makes sense. But typically what you do really when you're doing these things is you do this experimentally. And it's one of the reasons why I would want us to focus a bit more on experimentation, right? The importance of conducting experiments to try and determine, right, the importance of a given feature, ideally. So more on that though, I think in subsequent interactions here. Hope this is making sense. I don't know. Yes, is a question?
Yes, Doc.
Yes.
I noticed the references we're using, what we're using to check when we're doing the encoding, they've been simplified to their root forms. Simplified to their root forms.
Yeah.
But when you are showcasing the demo, you only tokenized, then deduplicated. You created a set, then you went against that. But here I noticed there's also stemming. Is that a step we need to take as well?
Yeah. Well, so yeah, thanks for that question. I mean, my assumption here is we are not my assumption. I think you mentioned we are building upon what we've done here. What when you're transforming, remember there's a journey we are following here, right? Business understanding, if you remember, BU. Data understanding, DU, right? If you remember, right? And then data preparation, DP, which is where we are at here. Now, when we are DP, right, data preparation, if we are working with text, it turns out that, well, we are assuming here that you've already performed the pre-processing operations. And you have got to, because, and I think I've showcased this, right? I've explained why. You have got to, because if you don't, you're probably going to end up with a model that is not effective, is it? Observe. I hope people are getting the point here.
No, I think I've gotten it. The fact that you've mentioned that we assumed that has been taken care of, I think is fine. I thought it was deliberate.
No, it wasn't actually. It's you have to. So you have to, because remember, this is you would actually end up with a very dense vector, right? This is interesting here. I wonder if we can preempt this so that we're all on the same page. I don't know if people understand the question here. Maybe I can showcase even an example here. But the question was, I think when I was showcasing some of these examples, like this. This. I mean, I kind of like, I didn't case forward, right? We did not case forward, we didn't remove stop words, we have and for. But in a real world setting, when you're actually working on this, it turns out that what you're supposed to do is you perform all the appropriate text preprocessing operations. And I'm saying appropriate here because there are certain use cases where you may not want to remove stop words, where you may not want to stem. Okay? But in this example I'm showcasing here, we case forwarded, we stemmed as well. Right? We removed. Well, I don't think we removed. Did we? I don't know if we removed stop words here. Maybe not. I don't know. Maybe not. But what you notice is if you go to the notebooks, actually, these steps are properly presented. So we apply all those appropriate transformation techniques. I don't know if I should demonstrate this quickly. I guess it does no harm here, so that you have an appreciation of why this is important, right? Remember, we have this, and I want to use something wild here. I'm going to use this. I'm going to use, I've already imported pandas. I'll use var unza dspace pd.read csv. These are already done in here, right? In design playground. Now, if you look at, I don't know if you remember this data set here, but there's a particular field that has textual content, yeah? The titles, yeah? So if you look at the titles here, assume we want to play around with titles, is it? One of the things we have got to do here is we have to, to simplify things, colleagues, I'm just going to case forward, right? I'll just case forward. Not lower, it's lower. I'm just going to case forward these things, and then I'll create, I'm just going to create title law or something like that, right? So that I just have title law. Something like this or something like that, right? So assume we have this data set, yeah? It's already normalized. Assume the other things have been done here. We've removed stop words, and in fact, I'm just going to say I'll deliberately not remove any stop words, although you can remove them using count vectorizer if you will, right? If you go in sklen sometimes when you don't do these things a lot here, feature extraction dot text, you will find this is where you will find TF-IDF vectorize, and but what I want to use here is simple one here. I'll use I want to use count vectorizer. This is where you find count vectorizer. So what I'm going to do is I'm going to say from sklen dot feature extraction dot text. I'm going to import count vectorizer. In fact, I import everything here, but I want to import count vectorizer. So I import everything, including some of these weird things I haven't even used. The hashing vectorizer, I have no idea what this is. But we're going to use count vectorizer, demonstrate this, and TF-IDF, right? For this particular lecture series here. So what we can then do is we ideally would have to first of all get the corpus. Our corpus is going to be Jesus Christ, is it this? Okay, I'm going to get this, and then what I can do is I'm going to create count vectorize or something like that. Vectorizer is going to be equal to, I'm going to create an instance of vectorizer, and I won't really use any other funny parameters here, but doesn't matter, maybe not. And then what I can do here is I can say I'm going to fit and transform here, is it? I'm going to create a bag of words model. This is our matrix. I'm going to get the instance of vectorizer here, and I'm going to fit it, is it? Fit and transform, right? But what am I fitting and transforming? I'm fitting and transforming this thing here. Okay? Now copy this. Christ. What I'm going to do here is I'm going to say dot funa. Again, we're doing a lot of assumptions here. There won't work here. Okay. And of course, you can check some of these things, the type and stuff, right? So in other words, I've fit and transformed it. I've created like a matrix, right? Now here's the thing, right? Here's the thing. If I do a shape, if I go to Unza DSpace, right? If you remember, in fact, if I go to Unza DSpace, that's the title here, title OR. We have 1,833 observations, right? Lines, is it? Records, right? And these records are like this. I mean, you can do the usual, right? Head and stuff. Maybe I just want to view one or something like that, right? And transpose if you want to, like this. They're like this. These records. Each record has these attributes, right? But the attribute that we're interested in is this feature here, the title, in other words. Now, the 1,883. The thing that I've created here is matrix. I've vectorized it, right? If I check the shape here, you notice something, right? It's the same 1,833 records, observations, but the matrix that I've created here, and I haven't even used, I'll talk about this just now, but the matrix that I've created has 4,777 columns. Is this making sense? I don't know if it's making sense here. And in fact, one of the things you can do is you can get the vectorizer here, var bag of words, count vectorizer dot get feature names out. So in other words, then the things that I've extracted, you see these things here. You may not see these, though. I don't know. Maybe you can. What type is this? An ND array, NumPy array object, right? If it's an NumPy array object, we can check the dimensions here. NDM. Okay, 1D. It's 1D object. It's a string. If it's a 1D object, we can also check the shape also. If it's a 1D object, then it makes life a lot easier. What we can do is we can say, I want to convert this into a list, right? So in other words, the thing that I've created, I don't know if it's making sense. I hope it is. Come on. The thing that I've created, yeah, is what you're seeing here. I have gotten, let me see if I can make this a lot more intuitive here. Wow. I'm going to say var underbar Unza DSpace. I just want one record. Observe. I'm going to get this. Oh, shoot. Sorry about that. I'm just going to copy this here again. Then I will copy this. Sometimes, colleagues, is confusion here. I don't know, comma here. Don't know why this is. I'm just going to do this here. Space. And you know what I want to do? I want to transpose these actually. I want to transpose these. Wow. Formatted text. It's okay. I can transpose them later on. I'll create a comma here. This is what I have. And then I'll transpose them again because I want to convert them to the original form, yeah? Like this. So observe. We have, and I don't need this extra field here. The records, those 1,800 and I don't know how many here, they're like this, right? Yeah? This is messed up here, but you get the point, colleagues. It's supposed to be here, creator, And what subject is here, creator has a huge space, which is horrible stuff, but the subject is not there, some stuff is not there. But here's the thing. It's like the original data set is like so. There are 1,833 of such entries. This is entry number 1. There's likely another entry here, 1,800 of them. Now, what I've done is, it's like I'm anticipating that I'm going to have to, I'm anticipating that, or I've figured out, maybe during business understanding or exploratory data analysis, that this is an important feature that I want to use, right? But for me to use text, I need to transform it into numbers. How do I transform it into numbers? I vectorize this. So what I've done is, for me to vectorize this, and we'll talk about these concepts, right? I need to get all the unique terms in the corpus. So I look at all the individual words in the 1,833 documents, the titles, like the individual words like morphological, characterization, and stuff, and then I get unique entries. Once I get those unique entries, I string them together, right? I use that as a basis to create additional columns in my data frame, right? So in other words, I am now going to come here, and then I'm going to get all of these terms you're seeing here. This is making sense at now. I'm going to get all of these terms you're seeing here, right? I've deliberately converted this into it. So I'll have of, what the? I'll have of, I don't know though. Maybe I could have copied some of these. I can't copy everything though. It would be nice though. But I can't copy everything. But I want to just get, for people to understand anyway. I don't know if they will. But I have these, right? I have these terms here. I'm going to copy some of them. And you begin to notice, that's why Lighton was saying Excel here, pandas is appropriate, not Excel or something. This wouldn't work, right? So what I'm going to do here is I'm just going to replace the single quotes here with nothing, like that. And then I'm going to copy these things here. And then what I'm going to do is I'm going to paste them here. And then I'm just going to do a text to columns here, right? And just say I want a comma here. So in other words, and I've just copied some of them. So when I transform it, right, I have got to do this. I'm creating a new field which is going to be like so. For each of those records, 1,833 records, you're going to have these additional columns that you're creating. Now, or here, right, I have 4,777 of them. I don't know if you were paying attention, colleagues. Here. These are 4,777 terms. Now you can imagine how many more I was going to have if I did not case forward. Huh? You understand? If I didn't case forward, I would have more of these. I can have less of these if I apply lemmatization or stemming. Forget about those things. I'm using unigrams by default here, right? I would potentially have more things if I use, we'll talk about this, by the way, we are getting ahead of ourselves, but this is fine. I guess we are setting the stage here to contextualize things. What I could have done is I could have specified my n-gram range when I'm creating this process I'm going through. By the way, we'll go through this just now here. But why? I can create another one though also, because I don't want to mess up this one. Is it? I don't know. I can create another one. This process I was going through, I don't know if you were paying attention, maybe not, but it's okay. I'll create BG here for bigram, but in here I'll say n-gram help count vectorizer, right? I'm trying to choose this here. By default, you're using unigrams here, but what I want to do is I want to say count vectorizer BG. We'll look at this just now. And then I'll just say count vectorizer, and then I'll say n-gram range, I want unigrams and bigrams, 1 to 2. Okay? So I want to get individual weights, and I want to also get bigrams, right? Pairs of weights. I do that, and we're going to go to, I want us to follow this thing here, the procedure, the process we're following here. And then I'll create the BG here, right? So var bag of weights matrix, I'll create this as BG, and then this is going to be underbar BG, like this, right? So I've now created, excuse me, I've created an instance of count vectorizer that uses unigrams and bigrams here. Initially, by default, if you looked at the help I showcased, I'm using unigrams, right? Or it makes sense just now here. Okay? And then what I'm going to do now is I'm going to showcase something here. var count vectorizer dot get features out. You may not get vectorizer BG. What you notice now is, unlike the first one where I just have unique weights, I now have pairs of weights, right? So they're individual weights and pairs of weights. And true to that, if I count this, excuse me, if I get the length, I now have 19,057 columns. In other words, right? I don't know if you get the thing here, what I'm trying to get at. The importance of applying those text preprocessing techniques is there's this concept called dimensionality reduction, right? You want, and it's all centered around compute resources really, but you want the vector you're working with to be as small as possible. You know, so part of what you do is you case forward, you stem and all those things, right? Because the moment you start tweaking these hyperparameters, like you say, by the way, typically in a real world setting, you don't work with bigrams, by the way, you work with trigrams, right? So you want to get single weights, pairs of weights, and triplicates, right? So it's instead of 1,2, it would be 1,3 or something like that. Now, the problem here is this thing increases in size, right? It increases in size. And so the goal is to, and I think there should be, by the way, like I don't know if this is making sense here. So the way that you partly reduce this is you stem, you remove commas. Numbers are useless, right? It's like, why would you want to create a matrix where you have this as a column, 10, 1,000? This is rubbish. You don't need this, right? So all of these, in a real world setting, you'd remove all of these columns are not supposed to be there. These things that are numbers. What else? Stop words, right? You don't need stop words. Why don't you need stop words? Well, in all likelihood, these common words here are going to be in almost all the documents. And if they're in all the documents, what's the point of including them? If this makes sense. And they're kind of like things that you can do as parameters in count vectorizer and TF-IDF. But we're getting ahead of ourselves. I wanted to answer the important question that was asked. Why did I not apply those text processing techniques? I was assuming that has been done. And this is what we're doing here. We're assuming it has been done. And it has got to be done, right? Because you're trying to reduce the size of the vector. By the way, you don't have to worry about the size of the vector here. It's like the bag of words BG here. If you want to get to array or something like that, to array or something like that, right? So you can get this vector if you want. This is what is this? It's a NumPy array object, right? Yeah, it's a NumPy array object. So what you can do here is you can say, if you have this, you can combine this with, with this. The count vectorizer BG dot. You want to make sure that these things are the same, is it? for this to work, right? Sometimes you mix things up, but if you're using a notebook, you no need to worry here. I guess pd.dataFrame or something like that. And then I'm going to get this thing that I had here, var underbar bag of words matrix bg. Come on, bg. Dot to array like this, and then I'm just going to say var count vectorizer bg dot get features like this, right? So ultimately, and if I can create this, I can actually create this as I'm going to create a new one here, unza dspace bg or something like that. So I've just created kind of like because this thing is a dense this thing here, you won't be able to. It's not quite intuitive for you to view these things. Observe, if I say I get this var bag of words matrix bg here, if I check the type here, it's a sparse matrix, right? Usually it's you won't be able to view. You can't easily view things here. It's one way of conserving space here. It's compressed kind of, right? So if you want to view this, you can unroll it. And this is what I was doing here. I'm unrolling it by creating a completely new this. I've created a data frame, right? With those 19,057 57, what do you call this? 57 columns, right? Just to showcase to you that this is insane. And I'll just view one record. I can transpose it, right? I have OV 2010. You see this? In fact, yeah, OV 2010 and stuff like that. I don't know if this is making sense. But anyways, I was just wanting to kind of answer the important question that was asked here. Hopefully, this helps in answering that question. But you see, there are some basics or fundamental kind of concepts that we need to appreciate when we're working with text here. Some of these terms I was using when I went well ahead here, but that's fine. It turns out that when you are working with textual content, yeah, collectively what you are working with is a data set, right? Like in our case, it's a data set of titles for all dissertations at the University of Zambia. These are the titles of all dissertations, right? There are 1,833 such titles, right? Title 1, Title 2, Title 3, Title 4, blah, 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 Title 1,833 of them. Okay, so usually when you're working on a problem, you work with chunks of text, is it? A data set. Now, when you're working with textual content, that data set is referred to as a corpus, right? It's referred to as a corpus. So a corpus will comprise of a collection of so-called documents, right? This is a document. This is a document. This is a document. The chunk of text associated with each individual observation or record is a document, right? Now, it turns out that depends really, but a document, a nice way of defining a document is it's a set of terms, right, associated with an observation. And it's a bit vague here, right? But the reason you want it to be vague is because you can view these terms from so many different perspectives, right? In some cases, you may be working on a problem where you are analyzing documents at work, maybe reports, right? So there are certain types of reports that are produced by marketing, and you're building this NLP model or something, like for topic modeling or something. You can view a document as being an actual document, that actual document itself, the entire document, right? So it can span multiple pages. or it can be an aspect of an existing document. Like, maybe I'm just interested in analyzing titles for dissertations. So I'll go into this dissertation that has multiple pages, and I just want to extract the title, that's it. Or I can view the document or the set of terms to comprise a particular section of a document. Let's say I just want to analyze abstracts, okay? Or I just want to analyze the introduction sections. Or, guess what? I hope I'm to get myself here. I was actually on Reddit. I don't know if this is good enough. I was looking for a way here of sorting thing here, but maybe I'll use something that is familiar to all of us, I guess. I don't know, maybe. Or your documents can be, imagine you are analyzing the things that KBN News posts because government has approached you, right? Some intelligence wing, I guess. They're telling you, no, we see that there are certain media houses that are biased. They're in cahoots with the opposition. So what we want you to do is to prove this, right? Go and analyze all the posts that they have posted on their Facebook page so that we try and assess their biasness, right? What you'd be doing is you'd be analyzing posts, is it? So you go to the KBN TV News page, and what you'd be doing is you'd be harvesting, you get these, what is it? These individual posts, like this is a post here, this one, this is another post here, including the image, this is another post here, this is another post. So these things that I'm calling posts here, these would be your documents, is it? But what is that now? These would be your documents. It gets better, right? You may be interested in finding out people's perceptions, right, about a post that has been posted by KBN News. Like there's a post that has a lot of comments or something like that. Usually Zambian Watchdog, I guess, but has usually a lot of. It's not a very popular thing. I like it. I like this page. I liked this page. It's in my stream because I liked it, but it's not as popular as Zambian Watchdog. If you got Zambian Watchdog, right? I think Zambian Watchdog is better. 1.5 million followers. If you got Zambian Watchdog, right? You notice that some posts, like this one, I'm sure it's 348 comments, right? So what you can say is, maybe you're working on a problem where you are analyzing comments. Now you're sitting there and thinking, well, but Lighton, why would we be wanting to analyze comments? Well, you're looking at people's reactions towards the post, right? There are certain posts that may be politically inclined, for instance. And so you want to see, right, where are people leaning more towards? Is it towards the current government or something? You know, are they in support of what is happening with, I guess, the Barry or something, or not, or something like that, right? In NLP, it's called sentiment analysis, right? So you're trying to see if the comments are more positive or more negative towards whatever is being talked about or something like that. Now, that's neither here nor there. We're not discussing NLP here, right? But what I'm trying to say is that these comments here, like these would be documents, right? Because your interest would be, I'm going to harvest all the comments for this post here to try and determine the sentiments that people have towards whatever has been posted. So what I'm going to do is I'm going to analyze these individual comments here. For you to analyze the comments, you collect them and then you view these individual comments here as documents. When you collect these 348 comments, they will make up what we are calling a corpus, right? The collection of documents. The comments will be the documents. Now, the documents themselves, you know, are made up of units, is it? Right? Units. Or tokens, in other words, use the word tokens here. And typically these tokens would be terms or words, right? So a document like this, comment from Yeresani Maseko, will have the tokens let's talk about database, note, dead, and stories, right? So these will be the individual terms or tokens. I want to use the word token. It turns out, in as much as most of these problems that involve text will typically lead you down the path where you are viewing your tokens as words, the things that are separated by spaces. There are certain unique instances where you may be interested in analyzing sentences, right? So especially if you're working with long documents, like imagine you're analyzing news items, for instance, or documents, reports at work. You don't look at words, maybe you want to analyze sentences, right? So your sentences will be your tokens. And there are libraries that you can use, easy libraries that you can use to extract sentences from a chunk of text, or you can build your own heuristic if you want to, right? You're just checking for maybe full stops as a brute force heuristic, if that makes sense. Okay, so in other words, this is some of the key kind of terminologies where you have your corpus, right? It's a collection of all the documents making up your data set. And you must remember here, right, that your data set may actually comprise of different attributes, as is the case for this UNZA DSpace thing here. It has 9 attributes. There's identifier, there's container ID, there's ingestion date. There are ordinal attributes, there are categorical attributes, categorical, and then there's text or content as well, right? So we're saying what is going to comprise our corpus is a small part of the entire data set. In other words, we're getting a slice of one of the fields, ideally, and we're analyzing this. You see later on that when you kind of like implement this, right, at some point, what you do is like you merge these things together, and then you experimentally determine a combination of these different features once transformed that will result in a more effective model, if you will, if that makes sense really. So you have your corpus, which is a collection of documents, okay? I have an example here. Typically this will be represented as a data frame, right? Or it could be a series. In my case, for the UNZA DSpace thing, my corpus is this. My corpus comprises of 1,833 documents, right? This is my corpus here. My corpus is a pandas series. Okay? Can be a data frame if I want to, doesn't matter, nobody cares. Can be a data frame, but you get the point, you get the drift. In the students at risk of failing thing, CS students here, there's a field, because I'm using this as an example, in the notebooks that I've shared here. There's a field called motivation, right? This. Out of these 69, right? If you remember, shape. There's 70 now because I've derived this new one here, but there's 69. Out of these 69 attributes, this is one of those attributes that has text, is it? And I can say is now here, is in it. I don't want this here. I want, and I'm going to get what? I'm going to get this. There's a field that has text or content, this, right? So in the student performance database or student at risk of failing dataset, this field here comprises of this slice here. This is a series, is it? This is my corpus. Okay, I can convert it into data frame if you wish. Nobody cares. It's a data frame, right? This. In other words, this, right, is my corpus. In my corpus, I have documents, is it? Right? The values associated with each observation. Document document, 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 document. Right? If I go back to this, the UNZA DSpace repository, document, 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 document. Okay? And then within the document, you have the individual words, the terms, right? And I'm showcasing examples in terms of the document here. It's an individual term. So for each document will comprise of, is made up of, in this particular case, we're defining our terms as words, is it our tokens? Let's use the word token here. Tokens, right? Or terms, right? The things that make up a document. Right? So we go to, what we can do here is we can say, we can, not data frame here, we can use a series here and just say, we're trying to get a sense here. So for each one of these documents, right, in the UNZA DSpace thing here, document morphological characterization of law, blah, 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 is made up of these terms, right? Morphological characterization of law, right? And stuff like this. And what you begin to notice really is that these things are going to be, they're going to have different lengths, is it? They'll vary, the lengths will vary because they're made up of different terms, right? If this is making sense, but it's neither here nor there. If that is making sense, yes. So, and of course, I mean, what we are assuming here is that the terms at some point will have to be pre-processed, right? Right? And this brings us to our discussion of this whole process of tokenization, right? Because we are saying that a document is made up of units, right? Of words. Typically, the unit uses a word, right? But it can be a sentence, it can be a paragraph. If imagine you're analyzing a manuscript, right? Dissertations for students. The introduction will have paragraphs, is it? Results will have paragraphs. So maybe you want to analyze them from paragraphs. Yeah? Imagine you're analyzing the Bible. Yeah? The Bible will have what do you call this? Verses, right? So those would be like your units. So you tokenize. The process of tokenization is really splitting up of the document in its constituent, I want to say, okay, words anyway. Words, right? Because a sentence also comprises of words here. Okay, so this process of splitting up that document is called tokenization here. And so what we're saying here, there's a number of strategies that you can use to tokenize here these words, right? Like for instance, you can create a vector of all possible words and then you count, right? The number of times that a word appears in a document or something like that. Anyway, so tokenization, right? You're splitting up. And you notice here that, tokenizing is not that difficult, except, I'm kind of using a shortcut here, but tokenizing means, what you'd have to do is, when you get your individual, you have a series like this, you are looping through each of these words, and then you are splitting them up somehow. Like if you want to split them into words using a space here, you're saying, get this for var doc in here. Get the document, excuse me, and because it's a string, is it? Split it, right? So you're going to split it. All the words here, splitting them like this. Split it into words or something like that. Yeah, if this is making sense. Okay, so what we're saying here is that, remember the reason why we are explaining all of this is we want to understand exactly how we are converting words into numbers here. Right? We'll start with the bag of words model here. So motivation for why we are converting this into numbers is that obviously these estimators that we want to use as part of modeling in here. The estimators that we are using in modeling phase number 4 here expect the output from data preparation to comprise of typically it's numeric values. So if we have text, how do we convert text into numeric? Well, there are a number of techniques, like we can use the bag of words model, right? Okay, so the idea is simple here. Once we tokenize each document, we can generate term frequencies for each of the terms in that document, ideally, right? So that your vector is going to represent the frequencies or the occurrences of each term in your corpus. Okay, it turns out that before the advent of semantic search here, once upon a time, this was a crucial part of information retrieval, really. That's neither here nor there. So the goal here is we want to move from here to numbers. It's like, how do we do this, right? The bag of words model is the simplest way of doing this. Don't know. Okay. We want to move to here, right? Well, so already, if you remember at the very beginning, I was showcasing how this can easily be done. I was saying, well, what we can do is we can run hot code, but in actual fact, you don't really do that. What you do is you get the unique terms that you have, right? I don't know if you remember the unique terms. The unique terms would be, remember, we have a corpus that has documents. Documents have terms, right? These individual words here. So for each document, we get all the terms, right? If we have 10 documents, we get terms for each of the 10 documents. And then we combine them and get the unique terms, okay? So everything that exists in all the documents, whether it exists or not in some documents, everything. That is what you use as a basis, yeah? As a basis to create this vector, right? So your goal is to create this vector here. This vector is going to have all the unique words in your corpus. Now, it goes without saying that for some documents, some words will not exist. And obviously, that's fine, right? You just want to make sure that this thing here has a common size. The size has got to be the same of this vector. In other words, the number of columns for each of the records must be the same. And the only way you can do this is you create a unique kind of vector, something like that, right? I don't know if there's I think there's we can go through a heuristic here. So you see, the heuristic is, and I don't know if there's I do apologize for the dings here, right? I can't even go to, I want to go there and switch it off or something, but that's neither here nor there. But so you have your corpus, remember you have your corpus, you have your document, you have your terms, right? Or let's just say token, or the terms. And we're going to get some examples here so we kind of understand here. We're going to get some examples of this, right? Something like this, right? So this is our corpus or something, all right? And it turns out for us to build this term frequency, right? We're saying, well, what we want to do is we are going to, for, I guess, I don't know if it's step 1 or something, for each document in the corpus, for each document in the corpus, I'm going to say get terms in the document. I'm going to say for all, just step 2 here is get unique terms common in all documents. Yeah. Ding dongs here. So we get the unique terms here, and then what we're going to then do is, and then it's step. I'll call this step 1B here, I guess. So we are constructing first. We are constructing first this vector or this list that is going to comprise of unique terms, ideally. Okay. Once we construct that, we're going to say for each document, I'm going to say count number of for each document, and as I say 2A here, for each term I'll call this here. Count the number of count or get frequency of term, right? So the idea here is you're saying you're going to first of all construct. You're wanting to construct this. You're wanting to construct this this vector that comprises of unique terms, right? Which should be fairly simple here. And then afterwards, you start looping through each document, right? In fact, it's like for each document, you start looping through. It's here, not for each term here. So for each term, I'll just say for each unique term, get frequency of term in document. If this is making sense, that's much better, much more intuitive. In fact, this is how count vectorizer works, right? In other words, it's a very trivial heuristic. Is it? So you can implement this actually if you think about it, right? It's like you're saying, I'm going to first of all compile. We can kind of implement this to a certain extent, is it? I'm going to say var unser DSpace unique terms. I don't know how you think you can quickly get the unique terms here, colleagues. I'm going to say var DSpace unique terms. Boom, empty list, right? Like that. Okay, so this is, I'm just going to create a list. I'll dump them in a list. I'll fix it later on here. Unique terms here. I created an empty list. And then what I'm going to do is I'm going to say I want to look through here, right? For this document in here, for this document in here, for each of these documents, what I'm going to do is I'm going to split this. Observe. I want to say var doc.split, right? I want to split each document so that I have like this list here. But I've already created this, right? This empty list. So what I can do here is say for each document, I'm going to say get this empty list I've created, this, and just append or something like that, like so, right? No, actually, not append, because it's going to be a list within a list here. I'm going to say this, just add it here. I want to add the list here. If this is making sense, right? So that ultimately I'm going to have this thing here, which has now this has all the terms from the document. I've looked through them. I think I have. I can check though. I don't know. I think, yeah, I've looked through them, right? But remember, a list will have duplicates, yeah? You know, in fact, I dare you, look at this. I can say, well, this dot count, let's see the number of ands that are in here. 1078 ands, yeah? How about the word there? 682. How about the word Zambia or something? I don't know. 560 or something like that, right? So, but what I want is, I want to create these unique terms here, right? I want to create these unique terms, and I shouldn't have called these unique terms here. I should have done this here. I can create this by converting this into a set, right? These are going to be, and then convert this back into a list because I like lists myself. So now this is not going to be the same length, right? This is now 5,576. So initially, the list that I've created, yeah, it has 28,837 terms. But for me to get the unique terms, when I get the unique terms, I'll get 5,000. I've actually drastically reduced it, 5,000 and whatever here. So I'll just call this UNZA DSpace. Instead of unique, I'll call this unique tokens. I hope unique tokens or something is going to be equal to this here. Right? So UNZA DSpace unique tokens will have the 5,000 or so words that I need. So these are the unique terms. Now that I have the unique terms, right? I have the unique terms. It's like 4 loops. I mean, you can be smart about this. Doesn't matter. Nobody cares though. And then for you now to build the frequencies that you need, right? It turns out that what you want now is for each of these documents, right? For each document, and I'll showcase this. It's kind of like an example document. It's like we can have an example document, I guess. Maybe not. I think we can include an example document. For each example document, it's like you're going to say, I am going to build for each example for each document. I want to build something that will be like so. Observe. When I'm looping through this, right? These 5,000 or so words, and these are not preprocessed, it doesn't matter, nobody cares. I'm going to get the word like fasting or fasting, and what I'll do is, I'll do this. I'll have fasting, and then I'll have the frequency here, maybe it's 10 times. And then I will count Africa. How many times does Africa exist? I'll get the count as well, maybe 5 times, but in each document. So for each document, I want to build something like this. Right? So it's like, how do I do this? Well, what I can do then is I can say for var doc, the same loop actually I had before. For each document, as I'm looping through here, because I already have the list here, right? What I can do is I can say, oh, wow, I want to build, you know what I'm going to do? I'm going to just, I think what would be easier here is, let's create a function. I think it would be easier to create, but it's fine anyway, for a document in that, doesn't matter. What would have been easier is you get a function here, right? df, and then we'll just say, bag of words, dict or something, right? This takes in a document, and then what I want to do is I'm getting the document. When I get the document, I'm going to create var final dict to be equal to this, dict like this, right? I think it should work. I don't know, maybe not. So I'm creating a dictionary, right? This is going to be this is a final dictionary, right? But the way the final dictionary works is that I'm going to have to loop, is it? I'm going to say for var term, I'll call this token anyway, in var dot split or something like that. So when I split, I don't know, we can check the implementation or something, but I want us to do this stepwise together or something like that. So it's like we're saying, we're going to build a dictionary, right? When we have a document, we build a dictionary, which we're going to use it to kind of like hold the key value pairs, right? So the key is going to be the term, right? The term, colleagues, that is in here, up here. I hope it hasn't been obscured somewhere. Up here. There we go. In here, you need tokens. So it's like we're saying, and I made a mistake here. It shouldn't have been like this, right? It should be in here, is it? So it's like df fxn bag of weights dict var document, quite all right. Var the final dictionary, which is going to hold the values we want, and then we want to look for each of the tokens in here. We are going to say, and I hope this works here. This is a thing, no pseudocode here, colleagues. But we're going to say we want to count, is it? We want to count the number of times this token exists in the document, right? And we know that the document here, the document we're going to assume is coming from a pandas data frame. It's a series. So we are going to say var doc.split like this, dot count, right? So we want to count how many times this exists, right? And I can't remember the behavior of count here, if there's an error or something like that. So what we're going to do then is we're going to say var final dict, right? This token here is going to be mapped onto how many times it exists in the document or something like that. I think this should work. I guess, I don't know. And then we're going to say return var final dict. I think this should work, right? So that when we have our, it sounds simple really, I think, I don't know. When we have our, if it doesn't, we'll try and figure out if we can fix this here. If we have our list here, unser dspace, observe, unser dspace, and then this is a title lower like this. We can do an apply, and then we do a fxn, bow dict or something like that. Goodness, it's taking a while here. I hope it's working behind the scenes. You notice, it's brute force, but it's neither here nor there. I can't really feed it. I could, I guess, if I modify the text, but I wanted to apply it on the final. I want to apply it on the final. Okay, I'm going to do this, colleagues. I'm going to interrupt this, and then I'm going to say I want to check the first one. I want to check the first one. I don't know if this is making sense for you. You can see what is returned here. Let's check the second one. Crap. Where is it? You see now what is happening here. What is returned here? I'm checking the first entry here. I'll return the list here. I don't know if you can see anything that maybe can you see anything other than a zero, colleagues? After the full colon, don't know. This is the only way we can check if this thing is working. You know what I'm going to do? I'm going to check the first record here. Not ilog 1, but ilog 0. It's going to be a lot easier for us. And then what I'll do is I'll go all the way up. Okay, I'll have a whole bunch of space here. And then I'll go all the way up and just copy this chunk here and try and see if we can find anything that is not a 0. If not, I mean, we can probably figure out, the thing is that we have thousands and thousands of these things here. Yes, is there, hello? Hi. Yes, there's a comment.
I was suggesting why not load it into a data frame and then we filter out any that have a 0, just so we can check.
Yeah. So the reason why is I'm doing this stepwise. So I'm doing this stepwise, and what I have is I want to find what I have is what I have here is may not really work. May not really work. Just a minute. It's just going to come here and horrible stuff here. Ooh. Just copy this, open it from here. Anyways, but the thing here is that if our heuristic is correct, we should be able to raise the marker here. We should be able to see, and I don't know if I got the first one here or this is the first one. I'm going to check for morphology or something like that. Morphology. So what I'm doing, by the way, in case you're wondering what is going on here, is because I have gotten this, I want to check if this word here, morphological, is somewhere in here. And the there we go, morphological. There we go, beautiful. So isn't this nice? So morphological has 1, which is good. We've done the right thing. What else is there? We can actually print out, let's print out iloc 0 and see exactly how many words are there. There's morphological characterization of law and blah, 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 blah. In the thing with the titles, again, is that usually people use more or less like, it's unlikely that you find multiple words in there. I'm looking for a case where we have 2 words, at least 2 words. There we go. If I check for in the second document, and I'm going to do the same thing here. Yes, so when the second document at 1, right? Here. I'll call this iloc 1, and I'll get 1, right? If I open the second document, right, this iloc 1, raise this or something like that. We can check for certain words, because observe words like there's instruction based. And I don't know if this is what instruction based formative in. So instruction based formative assessment in selected colleges of education in Zambia, its use and factors affecting its use. And the word use is 2 times, the word in is 2 times as well. So if I come here and I check for, observe, I'll check for things like, I'm going to zoom in slightly so that we see here. First, by the way, I'm using kind of like, there's very weird terms here. But if I check for I'll start with Zambia. And don't say, oh, right, but Zambia here is 0. This is not Zambia. This is Lusaka, Zambia, because of how this is, right? Because of how some of the titles are formatted. But what I'm looking for is just the word Zambia. In fact, what I'll do is I'll just say Zambia like this, in a string like that. Should be 1. Where is it? Where are you, Zambia? And this is weird here. I don't know why I can't. You know, this is the reason why sometimes these tools that we use, right? I hate them also. I'll just go to my trusted. Zambia. Sorry, I'm using this, but I have to go to Zambia. Zambia. Where are you, Zambia? Oh, Zambia. 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 This, by the way, is not Zambia, it's Zambia, which is wrong. This is not Zambia because Zambia in parentheses and stuff. I'm looking for something that is just Zambia, not, this is not Zambia, this is Zambia Gwembe, if you can see. I'm looking for just Zambia, and I know I'll find it somewhere. This is Kasepa, Zambia, but the problem is a lot of Zambia Kitwe. I should have sorted them somehow as well, right? It would have been a lot easier, I guess. I will find it, I think. I'm hopeful. But the problem is that probably a lot of them also. That's horrible stuff. Okay, I know that I'm looking for something that has full colon and a 1. But there are a lot though. There's its, which is good, right? Its is there. This. It's 1 time. What else? Its, factors, based, Zambia. There we go. In fact, I was searching for this wrong thing. It's Zambia full colon, right? Not Zambia. It's Zambia full colon because it's like this. You see this? That's why I made a mistake. It's Zambia full colon. We didn't remove punctuations. But guess what? If we check in here, how about the word use, right? Use. You see this? Use has two entries here. Use full colon 2. What else? Because use has 1 and 2 here. Yeah? What else is there? In. In is supposed to be 2 of them. So if I come here and I check for in, like this, there will be 2 of them. So our heuristic kind of like works or something like that. But so the doesn't matter really, but I just wanted to, I'm just trying to, I was just trying to showcase to say, there's a way in which you can implement this heuristic, is it? This, right? And thankfully enough for us, in terms of things that come out of the box, you can actually take advantage of count vectorizer, right? To do this same thing that I'm just from showcasing, yeah? I had showcased, if you remember, the process I was going through. Instead of you doing this, yeah, what you can do is you can use scikit-learn, right? So we've installed scikit-learn or Dandy here and stuff. So what do? You load your data on your data frame, right? Import pandas as PD, right? And then in sklearn here, you will find, if you remember, I said from sklearn dot feature extraction dot text, because you're working with text. Import, there's count vectorizer, there's a whole range of things. If you remember, I did this, yeah? I did sklearn dot feature extraction dot text, right? What we're just from looking at is a heuristic for, and it may not have been implemented using a brute force approach I've just showcased here, but it's this count vectorizer. Okay, so all you do is you say import. The process you go through is you say import pandas as PD, and then you say from sklearn dot feature extraction dot text import. You can explicitly import count vectorizer like so, or you can just say import everything. It's easier, asterisk. And then what do? You have the data quite right, right? The data that you want to vectorize, the data that you want to convert to numeric, right? You're converting them into a bag of words model, if you will. So what you do is you first of all create an instance, right, of count vectorize. So instantiate. So I'll say count vec unza dspace is going to be equal to count vectorizer, like so. Now, of course, I mean, there's a whole range of parameters that you can feed count vectorizer. Surprise, surprise, you can actually remove stop words right here, which makes life a lot easier, right? You can specify the n-grams that you want to use. Called n-grams here is a combination of words, right? Units of words, tokens you want to work with. One unit is the default, so it's 1,1 n gram range, n gram underbar range. Yeah, it's a tuple 1,1. We'll look at the help. Maybe we can look at, I don't know. But anyway, so you create a count vectorizer, boom. Okay? When you create the count vectorizer, this instance of count vectorizer, what you do is you must fit it. It's like you're training it or something. You fit it, right? Count vec dot fit. You fit and transform. And what you're fitting and transforming is the corpus. Now, corpus is a series, right? Observe. Corpus is going to be a series. It's going to be this. Unza dspace. It's going to be something like this, right? So what you do is you say, I want to fit and transform this corpus, the pre-processed text, okay? And what it does, you notice, is it creates a sparse matrix, is it? And generally, because there's more things that you've got to do, you typically would create a variable for this, yeah? So I'll just call this count vec dspace. I'll call this a matrix, right? The sparse matrix that I'm creating. Yeah? And this is typically, this will make it possible for you to check the sparse matrix type. But what you can do is you can check the shape of this just to be certain that the corpus that you're working with is exactly the same, right, in terms of size. So 1,883 observations, and the resulting kind of columns that I've created are 4,777 of them. Okay? And typically, I mean, depending on how you want to implement this, I'll showcase exactly how you get to kind of like use this to learn a model or something like that. More on that, I think, Saturday or something like that. Doesn't matter. Yeah. But if in case you want to see, right, you want to unroll this sparse matrix, because you can't view it just like so, right? I mean, there are methods that you can use, like to array, for instance. This is going to return, I believe it's an ND array object or something like that, right? Yep, an NumPy array object. But typically, this is not very helpful, right? Because this is what? NDIM. This is 2-dimension, right? Because it turns out that so what this thing is doing is it's returning a 2-dimensional array where if I get the element at the first position here, it's going to return, it's more or less like a list or something, or elements that are associated with the title that has morphological characterization, right? If you notice here, this 0, 0, 0. These represent these. This is a position that is aligned with, oh my goodness, it's aligned with var count_vec unza.get features, right? Out. Yeah, you see this? So for the element, for the vector which is at position 0 here, for the array at position 0, this is of, this is 10, this is 1000. If this is making sense, I don't know if this is making sense. I want to see if I can get, let's see here, vec vocabulary, I think it is. Beautiful. So observe, right? What vocabulary underbar does is it shows you in the vector that you've created, yeah? It shows you the position of each word, yeah? So the word vubwi is at position 4657, yeah? And so what I can do here is I can say, I want to check, because this is a dictionary, yeah? I want to check morphological. It's at position 2857. 2857, I'm going to go back here, observe. In here, this array that I've extracted, this, I've unrolled it from a two-dimensional array object, but this is going to have the number of elements in my vocabulary, right? For me to check the frequency associated with morphological characterization, what I'm going to do is I'm going to say count_vec matrix dot toArray, like this, 0, but I want to get the thing, this is the position 2857. 2857. Let me just see here. Guys, 2587. What the hell is this? I'm going to copy this. There's an extra alone thing here. This. Right? So it's telling me that the word morphological occurs one time. It gets better, right? Because I know that there's a document here, this document at 1, which has use occurring 2 times. How do I know use occurs 2 times? Well, I know, I guess, use occurs 2 times here, iloc 1, yeah? Is it? And then title lower. This thing has used 2 times, right? Use. So what I can do here is I can go back to my vocabulary, is it? And check, right? Can I say in vocabulary I want to check what position is used, right? It's at position 4553, right? Which is fine. It's the index position. It's at 4553. I'm gonna get the dense matrix and roll it into an array, right? And roll it into an array, 2D. But I want to get the second document which has the word used 2 times. This is the second document. It's too long here. These are ellipses here, indicate there's more stuff here. So but I want to say, I want then to check. I want to check how many times, because this is use, right? The word use. How many times does use occur in document number 1, at position 1, which is document 2? It occurs 2 times. If this is making sense, I don't know. I think it is. Anyways, but what you probably want to do here is, if you go to Count Vectorizer, you notice that the documentation has a couple of other things that you can do, because you know when you're playing around with text, there's a whole range of things that you may want to do, right? Crucial is things to do with the n-grams you want to work with. By default, it's unigrams you're working with. So you can create an instance of Count Vectorizer that you're working with trigrams, in which case this is going to be 1,3, right? So you'll be working with, if you do 1,3, you're telling Count Vectorizer to say you want to ensure that you account for unigrams, 1, bigrams, 2, trigrams, 3. So you have words that appear alone, pairs of words, and triplicates as well. If you just want to work with bigrams, it would be 2,2. If it's just trigrams, it would be 3,3. And in case you're wondering, but how do I figure out what to use here? What am I going to use? Well, you experiment. So you construct an experiment, right? You have this model, a model that uses unigrams, a model that uses bigrams, 2,2, a model that uses trigrams, 3,3, a model that uses unigrams and bigrams, both unigrams and bigrams, 1,2, a model that uses unigrams, bigrams, and trigrams, 1,3. A model that just uses bigrams and trigrams, 2,3, and stuff like that. You know, it's also there's a couple of like parameters that you can tweak here. A couple of other things that I have used myself in the past. Let me see here. Trying to see if I can find. I think it's maximum DF for something where you're specifying the proportion of words that you want to include, right? There are instances where you may remove stop words, but they're still common words. Like if you're working with documents from the University of Zambia, the word university is like a stop word. It's going to be common. So you might as well exclude it or something. So there's a way in which you can say, I want to make sure that I remove words that appear in less than 5% of the documents, or words that appear in more than 80% of the documents, or something like that. I don't know, that's neither here nor there. I don't have any thoughts about count vectorize or something. Observe, the reason, I must say this, one of the reasons why we are doing this is not only does text appear often, I mean, it's one of those widely used things, but almost everything that is in here. Almost everything has been deliberately crafted. These questions in mini project, this involves the use of text. Okay, so whether you like it or not, you're going to have to play around with the stuff we are from discussing. If this is making sense. I don't have any thoughts or questions or something like that, but maybe just to kind of mention that what you can do is you can use an alternative, right? I think I already hinted at the fact that one of the fundamental differences between TF-IDF when compared with count vectorizer is this notion that TF-IDF tends to pay particular attention to the importance of a term in the document relative to the entire corpus. Okay? Whereas the bag of words model just looks at, you are checking, right? How many times does the word use occur in my document? Because I know use is in my vocabulary, right? It's in the it's at least occurs in one of the documents in the corpus, right? So you're just counting, but that really is not very useful, right? What you want to do is you want to check the relative importance of that document, of that term, not just in the document, but relative to the entire corpus that you're analyzing. Okay. Now, I mean, what I have here is just a formula for TF-IDF. Don't really have to worry so much about this, I guess. It's neither here nor there, but I think what is important for us is to realize that for us to come up with an equivalent of what we've done with count vectorize bag of words model, what we have to do is we just have got to go through the same process where we create an instance, right? We create an instance of TF-IDF, but instead of count vectorizer, we're going to have TF-IDF vectorizer, right? And then what we then do is we do the same thing, right? Just creating an instance of TF-IDF vectorizer, and then what you do is you would create, I want to make sure that we're doing the same thing here. I want to create a matrix or something like that. Come on, matrix. Boom. What you do is you make sure that you fit and transform on the TF-IDF, right? This. And then I'm going to change this so that the matrix itself is for TF IDF, like so. Boom. So what I've done is I've created an instance of, I shouldn't have named it count vectorizer here. I should have just named it TF IDF vectorizer here. I mean, it doesn't matter though. So what I've done, I've created an instance of this vec, this, right? So I can do the same thing. I can get the features. But it turns out that the features are going to be the same. These are the same exact features, right? Exactly the same. The only difference that is going to be there is this matrix that I've created here. Come on, matrix TF-IDF. This, it's going to have slightly different values. Observe. I don't know if you can see here. This is like int64, right? These are integer values I have in my sparse matrix. But in this particular case, I have floating point numbers, right? Yeah, that's one of the obvious differences that is there. So what I can do is I can do the same to array like so, and then I get my array object. Now if I start unrolling, observe, I'm going to use, yeah? Observe. I want to get use. Jeez, this is not use though. I want to get use. Where is use? So for count vectorizer, right? The value for use is 2, right? Because I'm just counting how many times does use occur in here. Oh, it's like 2. But if I get the value, the same value for TF-IDF, you notice this? The number has changed. And this is important, right? This is important because if I check again, observe something. If I check unza dspace and then I get iloc 2.1, I guess, and then I get title log. Observe, use occurs 2 times, but so does in, right? Where does in exist? Oh, I don't know. Where does in exist? I don't know. var count vectorizer. Get vocabulary. I want in. In occurs at position 2115, yeah? So position 2115, if I check in document 1, what is the frequency of in? Shit. What is it? Sorry about that. What is the frequency of in? 2. Okay? What is the frequency of use? 2. Okay? Well, wait a minute. What is the frequency of, what is the value, TF-IDF value of in? Right? In 0.138 or 139. Okay? It was 2 for counting, which is the same as, in is the same as use, right? But when I use TF-IDF, in is not the same as use. The values are different, right? Use 0.139. In 0.468. In other words, right? Whereas count vectorizer seemingly suggests that use and in have the same relative level of importance for this document, right? The second document here at index 1. TF-IDF is telling us, no, that is not true, right? The word in is more important than the word use in this document. I hope this has kind of like made sense or something like that. And this is the example that I have here, right? Kind of doing this. Now, you know, I wanted to remind us about something, colleagues. If you remember, when we started discussing this course, at the very beginning, I told you something, right? If you remember, say, you know, when you look at studies that have been done by people, studies suggest that there are certain phases that require significantly more effort. I don't know if you can hear me here, because can you hear me, by the way? Because I can't see my. Maybe I'm talking.
Yes, we can.
Oh, thank you. I can't see myself on the screen here on my mobile device. But if you remember a discussion we had, right? We said that there's certain phases that require more effort. Now, I know we haven't looked at modeling yet, but you can already see that data preparation actually involves quite a bit here, right? Preprocessing, where you're deduplicating, you're handling null values, you're case forwarding, you're stemming if you're working with text, right? You're case forwarding, you're lemmatizing, you're stemming, you're removing punctuations and stuff, you're transforming, yeah? This is all part of data preparation. And what you'll notice with modeling, to be honest, is that there's very little to do there, right? Literally very little to do there. I mean, the only stuff that requires a little bit of effort, I guess, which we don't really focus more on in this course, is understanding maybe how these heuristics work or something. But you don't have to, right? You can view them as a black box, ideally. You know, so I thought I would remind you to say, as we're wrapping up this discussion of data preparation, what we're from discussing here is part of the reason why people that have done studies, right, in data mining pipelines, have determined or deduced that this requires quite a bit of effort. Okay, I don't know if there are any questions about term frequencies and transformation really, how we transform data. So a reminder here that we are from discussing this phase here, right? Data preparation. When we meet next, we're going to. I want to suggest maybe colleagues on what do you call this? On Saturday. On Saturday, maybe we can have a session, and we wrap up or something like that. Okay. I don't know if there are any questions about transformation or something. Yes, please.
Yeah, so I just want to find out just on what you were talking about when it comes to the process that is quite heavy when it comes to preparation of data. I mean, that the whole lot of a process. So does it mean that there are no tools that are that are automated to actually, maybe some tools that are actually specifically for this, that's where this process can be automated or something like that?
Well, I mean, tools are there. I mean, especially in the age of AI, I guess tools are there. But still, I mean, the question would be, and I'm trying to see here, right? I mean, so if you've been paying attention, you notice that most of the things we've been doing, I mean, quite involving, quite all right. But if you want one hot in code, there are functions that exist. You know, if you want to clean data, there's already inbuilt there are libraries that exist that can enable you to clean up the data or something. But it still doesn't take away that the fact that the amount of effort required is still significantly more. So there are tools there, quite a number of tools actually. In fact, if you are doing this in production, in some instances, again, depending on the problem, I guess, there are tools like Weka, for instance. I don't know if people have heard of Weka, right? Nice GUI-based application that kind of like obscures, right, a lot of these the gory details of what you'd be doing with I guess it's like Python and all those things. So tools are there actually. Tools are there. I'm trying to see here what else. But if you look at just the libraries that we've been using so far, most of the things, it's not like we've had to build to write like programs for most of these operations. They already exist, right? I don't know if I'm answering your question or something. Am I still online?
Yeah, I'm getting it.
Yeah. So there are tools actually. There are tools that are there. I mean, that your arsenal of tools that you use is dependent on the problem, right? So like for instance, I know, I mean, if you're working on NLP-centric problems, you find that certain libraries like Spacy will actually be able to make it a lot easier for you to do a lot of things that you'd have to manually do if you're not using that library, right? Like named entity recognition, for instance, that comes out of the box with Spacy. You know, so you already have like a way of identifying, given a chunk of text, identifying what do you call this? Entities that exist in text. All right.
Thank you.
I don't know if there are any other thoughts, colleagues, or questions. I think
I wanted to ask on the presentations.
Yes. Please go ahead.
During the test, you spoke of us having some presentations to add to the CA.
Yeah, we had a discussion. I think you joined us late. We had a discussion.
Yes.
There's an assignment that has been made available. I'll also share it on Google Classroom. It has all the details about the presentations. Next week, Wednesday, is when we're tentatively having these presentations virtually.
All right, thank you.
Yep. Okay. I'm going to let you... there's another hand up. Yes, please.
So my question is on...
sorry, your audio is a bit muffled. I don't know if you're using headsets or something. We can barely hear you. Hello? Yeah, I don't know if it's just me, but the audio is quite bad from Sinyani, right? We can let him know to just post the question in the chat or something. We will answer it or something like that. Yes, there's a hand up from Monga.
Yes, Doc. I also want to find out, about the test we wrote. Now,
Yes.
After, maybe someone might have even thought very hard. Is there, when is it likely that maybe the results will be out? Maybe if it's something that is out before the makeup, maybe somebody might ask to sit for a makeup. Is it something that is...
Well, I mean, I
can be
haven't finished marking. It's not a makeup, it's a deferred assessment, right? It's meant for people that haven't finished marking, but we have been instructed to finalize the CA and everything else before the fest. So I'm committing to making these things available before the fest. Yeah, but the assessment is a deferred assessment. It's meant for individuals that were unable to write because they were away and all that. This is the reason why I'm suggesting that we put in a little bit of effort in the mini project as well. Okay.
So in an event where maybe someone feels they didn't perform well in the first test, that means that they don't stand another chance.
No, unfortunately. So there's no, in other words, there's no makeup actually.
Okay.
Yeah. There's not going to be a makeup assessment, a makeup test, if you will. All right, colleagues, this is 2030. I'm going to let you go. I will be in touch. I want to suggest, I still feel for some of these concepts, right? The things we're going to cover towards the end here, you will certainly need them in part 2, maybe as a reminder or something. But also for those of you that are doing more advanced courses next term, I think it's important that we cover this. So I'll be in touch. I want to propose maybe an interaction Thursday or Friday or maybe Saturday or something. Thank you very much and enjoy the rest of your evening. Goodbye. Oh my goodness.